Hello, welcome to another episode of Yummy Data Science. I'm going to create some short episodes that feature uh, initiatives that I've led over the course of my work experience, which spans almost 30 years. And these initiatives have a combination of AI, machine learning, statistical modeling, lots of data, technology incorporated in them. So today I'm going to be talking about synthetic Medicare healthcare claims, how I led the creation of a robust and realistic environment. And the purpose of this environment was to accelerate analytics with real world data. Real world data that was synthetic. So let's get into it. I have quite a bit of prior experience and expertise in synthetic data, and this is an area of extreme interest. So, shameless self promotion here. I would love to talk to you about it if you have similar ideas or are thinking about the advantage of a synthetic healthcare data environment. In 2009, I was working at a company uh, which dealt with Medicaid patients, and we were evaluating a number of business intelligence tools. And so, in order to speed up that evaluation, selection, and adoption process, I created synthetic claims. Um, so then I use those synthetic claims to test out the various technologies, and this was really useful. Then, because I had such a great experience and so much fun in using SAS algorithms to create the synthetic data, I layered on this data intelligent patient journeys for my first book with SAS. And then in 2014, I co-created and leveraged large synthetic healthcare data sets to showcase industry applications, including performance and quality reporting. And that was for my second book, which deals with administrative healthcare data. So, data that is created for the purpose of financial reimbursement. And it had applications such as HEDIS reporting. It had applications such as continuous eligibility. And in order to showcase these applications and the code and the algorithms behind it, we needed really good data sets. And so the synthetic data came to the rescue yet again. And since then, since 2014, there have been many, many times where I've had to work with synthetic data. And so, indeed, I have advanced in my knowledge and experience of this of creation of synthetic healthcare data. And most recently, the initiative we are talking about is a 2024 initiative in which I led the creation of a synthetic virtual research data center. This is from Medicare, and it has Medicare data for about 60, this environment. VRDC has data for 60 million Americans. It is both in Databricks and in SAS, and I led the creation of a synthetic environment in Databricks. So first of all, what is VRDC? Like I've mentioned before, it has claims data for about 60 million Americans, 30 million of which are covered by a flavor of Medicare called Medicare fee-for-service. So for about 30 million, it has claims, all kinds of claims. So by all settings. So a setting could be, one example of a setting is a hospital. You go to a hospital, that's called the hospital setting, or you go see your provider. That would be the carrier setting, or you pick up a prescription, that's the pharmacy setting. And the VRDC environment has data for 60 million insured beneficiaries for pharmacy, and the rest of the data detailed by setting it has for the 30 million FFS beneficiaries fee for service. In addition to that, it has extensive enrollment data. So enrollment is like, when did a person come on Medicare? Did they leave for a few months? Did their eligibility lapse? Did they come back, etc. And so in building this synthetic environment, I incorporated all of those features by various settings. So the exact file layout, exactly which folders they were located in. Um, uh, Now, some useful resources in creating this synthetic environment. Um, I really admire Dr. Khalid El Imam. I hope I'm pronouncing his name correctly. Um, for a period of 6 months, I basically went on a OCD thing, and I devoured his books, papers, listened to his talks, and I have learned so much from him. So thank you for making all this amazing learning public. And I also got to know about Synthetic Data Vault, which is a Python library that now leverages Gen AI. So Gen AI has been instrumental in creating leaps, big, momentous leaps in how close synthetic data can be and realistic it can be, especially in healthcare. While we were building this environment, it incorporated the synthetic data vault, which is the Python library. And the key idea, without giving away any of the intellectual property, because it of course belongs to the company that I worked for, without giving any of this information away, what is known publicly in Dr. Imam's papers and in other papers is that if you start with some seed data, and actually you don't even need to have seed data. If you start with some seed data, it's a little bit easier. You start with a few handful of observations, and then if you know the distribution of the population, and how would I know the distribution of the population? Take the prevalence and incidence of diabetes, for example. Well, that's pretty well known. And Medicare has a plethora of freely available data sets that it publishes. So you could get the population statistics from those, and then you could get some seed data. Medicare also makes available the seed data. Um, some of it is older, some of it is newer, and the older one came from a time where many of the healthcare codes have changed. So the ICD, it used to be ICD 9, now it's ICD 10, and big differences between the two. So anyway, but the point is, you take some seed data, and you might have to use synthetic data creation to update that seed data. Um, um, but even if you don't have any seed data, you can create patient journeys, and then you could use Gen AI to fuzz them and to replicate them. And then you could layer on the population distributions on top, so that records are created in such a manner that they represent realistic and robust patient journeys. So, I get very excited about this. This is very useful. And let me talk about why it's useful. Well, the obvious reason why a synthetic healthcare environment is useful is that for learning purposes, you would not want your real data out there, right? So it's clear, for learning purposes. Then why might it be so for universities and students? This would be immensely beneficial. What is another scenario? Well, it would be beneficial to, say, health insurance companies, pharmaceutical companies, anywhere where healthcare claims data is analyzed. And why is that? Since they have the real thing. Well, generally, companies have their data broken out by whether it's a production environment or a test environment. And Yes, this data is available. The real thing is available in the production environment, but it may be very big, it may be very complex. So, when you are setting up your analysis or when you are doing initial coding, data engineering, feature engineering, modeling, you want to work in an environment that is fast, that is really rapid. And so you can test out and write out your data engineering pipelines and ML pipelines. This is important because it accelerates analytics, and it accelerates it not in the usual way. Like, okay, I'm going to take a research question, and instead of 4 weeks to answer this research question, I'm going to answer it in 1 week. No, that's not the way it accelerates it. The way it accelerates is it takes out the bumps in your process and it smoothens it out. Okay, what do I mean by the bumps in the process? Say you were like, okay, my question is, I want to analyze whether drug X or Y, which is more effective against diabetes. So I'm going to do cohort selection on this. And I have some a priori ideas about what my cohort should be. So I run it in the production. It takes a long time. Then I get my results back, and then I tweak it and I run it again. So this back and forth process is going to take time because the data is large. Well, if you had a test environment that mimicked the distributions, you could do this process much more quickly, and it could be way more iterative. So say you've gone through your cohort selection, you've done your data engineering, you're now doing machine learning, and you realize, oh my gosh, I need something else back at my data ingestion. But if you have that test environment, um, you can quickly go back, grab it, and run your pipelines again. So it smoothens out the bumps in your process, and by smoothening it, it accelerates your process. So thank you for listening to me. I love this area, and if you'd like to talk about it, reach out to me.